Hello, class. In lesson 3.3, we learned how to solve systems of equations by graphing. In lesson 3.4, we learned how to solve systems of equations by substitution. And in lesson 3.5, we're going to solve systems of equations by elimination. So essentially, we could take a system of equations and solve them three different ways: by graphing, by substitution, and now by elimination. I'm going to jump to a handout that I prepared. Whoops. And maybe you want to take a screenshot of this. I want to work out a few problems on my handout and then jump back to the book in my second video. Okay, so for this first video, I have some instructions here, right? Steps in solving equations by elimination. Step 1, arrange the equations so like terms line up. That means the x's should be over the x's and the y's should be over the y's. So to do that, I have to make a little tweak here. Let's just move this up a little bit. All right, so my tweak will be on this bottom equation. I'm going to rewrite this as y minus 2x equals 7. All I did was I switched the order here. And now you'll see on my first equation, my like terms are lined up. Equals 26, right? We want to do step 1 is done. Step 2 says, as needed, multiply one or both equations by numbers that make opposite coefficients in one variable. We don't need to do that because I have a 2x plus 2x on the first equation and a minus 2x on the bottom. So the plus or minus 2 are opposite coefficients, so I don't need to do anything there. Step 3 says add the equations to eliminate one variable, right? So because I have opposite coefficients in x, when I add these together, 2y plus 1y is 3y, 2x minus 2x is 0, and 26 plus 7 is 33. So you're left with 3y equals 33. And if I divide both sides by 3, you get y equals 11. Okay, so now y equals my 11, that's a good start, but that's just the y coordinate to my ordered pair. So I need to replace y either here or here with 11. So I'll use the bottom equation. I'm going to use this equation. So I'll rewrite it here. So I have minus 2x plus, now instead of y, I'm going to drop my 11 right here, right? Because y is equal to 11, right? So I drop the 11 in. So I'm left with negative 2x plus 11 equals 7. I subtract 11 from both sides. I get minus 2x equals, looks like negative 4. Divide both sides by negative 2. And you're left with x equals 2. All right, so the ordered pair is 2, 11. Now, if you want to check your work, remember, this is x, this is y. You can plug them back into the original equations to see if they are true, right? So if I put in x and y here, I should get this 26. If I put in x and y here, I should get that 7, right? So this is my solution. 2, 11, okay? And again, you should definitely do the check. Let's try another one. On the next page, okay, so the first step I want to do is I want to rewrite this so opposite coefficients line up. So let's get on that. So I have x minus 2y on the bottom on the second equation. So if I add 3y to both sides here, actually I'm going to put put it in the back of the x plus 3y, right? This top equation becomes 4x plus 3y equals 8. The bottom equation I'm not going to touch yet. X minus 2y equals 13. Now, before I can add these two equations together, I have to get opposite coefficients in either x or y. Okay, so this is where it gets a little tricky. I want to eliminate a variable. So since I already have positive 4x on the top, if I multiply this bottom equation by minus 4, look what happens. I end up with negative 4x plus 8y equals negative 52. You see what I did? I distributed the negative 4 all the way through. Okay? And why did I do that? Well, on the top, and let's change this red. Color's not so hot. On the top, I'm going to have 4x plus 3y equals 8. So now you can see why I picked negative 4, because on the top I have a positive 4 and a negative 4. They're going to cancel to give me 0 plus 11y equals negative 44. And if I divide by 11, I'm left with y equals negative 4. Okay. Now I could have multiplied this top by, say, negative 2 and the bottom by positive 3, and I would have had 6y on the top and negative 6y on the bottom. I could have went that route, but I just thought it was easier to multiply by negative 4 to eliminate the 4's. Okay. So now that I have y equals 4, I need to plug that into here or here. Right, so I'm going to use this bottom equation, and I'll write x minus 2 times, instead of y, I put in negative 4, because y equals negative 4, equals 13. So now I have x plus 8 equals 13. Subtract 8, I get x equals 5. Right, so the ordered pair would be 5, comma, negative 4. And that's my answer. And again, to do the check, plug in x equals 5 and y equals, negative 4 into the original equations and make sure that they both work. Okay, you have to do it to both equations, not just one. All right, I'm going to stop here, and we'll do a few more problems in the second video. Thank you for watching.